I'm quite happy to have Dr. Alexander Hüttenbrink here with us. He is co-founder and CEO from Kinexon. It's a young company. It was a startup, but now I think they are pretty successful, and so it will be great.
Yeah, thank you very much. Very good introduction. I try to now give you a bit more insights on really what is industrial IoT all about, and especially giving or presenting two real-life examples, two best practices, and also showing what is the impact and how IoT and industrial IoT can provide a competitive advantage. And this is hopefully something that helps for many of the people here in this show. The title is Real-Time IoT Connectivity and Localization for Measurable Benefits. And when we look at IoT, or especially industrial IoT, I want to talk about the simple promise of industrial IoT. So why do you do that? Or why is it there? Or why will it come? And the idea is basically that it will create value through connected and automated production logistics. So in the smart factory, the idea would be that there's everything connected, interacting, like being steered by an invisible, very intelligent hand, very optimally, and then therefore optimizing processes and reducing failures, stuff like that, and overall creating value. And when we look about people now already implementing or thinking about implementing IoT applications, the promise here is very, very clear. As I said, automation, stuff like that. But most people say they hope and they will optimize their processes, so making them more effective or more efficient. They believe that they can increase their productivity, their utilization rate, for instance, of equipment. But also, and this is very important, it's not only about, cost and stuff like that. It's also being prepared, for the needs and the requirements of the customers. So basically, we know that very customer-centric companies are very successful, like, for instance, Amazon. And so IoT can also help to fulfill the wishes and the needs and requirements of the customers. And I will talk later about this, what that means and how can that be enabled. And of course, production cost, reducing production cost is something they would expect. And this is also, for me, it also belongs to, optimizing business processes and stuff like that. But now, if we go a bit into more detail, there's a study from Deloitte here, and what are the opportunities of the smart factory? The smart factory, the opportunities for IoT is huge. It's about manufacturing operations, quality things, but also health and safety. But when you look at all the specific points, what you can do here in the future, one thing they all, or many of these things have in common, it's the key information is localization. So we say localization, or the information about the position and the status of an object, is like really one key ingredient for many, many IoT applications. It's like in our personal life, when we look at our smartphones, how we use it, so many location-based services. So Google Maps, Runtastic, all that stuff, but it all requires the information about where I am, for instance. And this is also true for many industrial IoT applications. And I will go a bit more into detail when we look now, what is the status quo currently? So when we look at machines on the shop floor, they make roughly, let's say, 1% of all the things on the shop floor. They are more or less well connected already. They have a management system what has emerged over the last 20, 30, 50 years, so the MES. And usually, where are the machines, right? Because they're static. But there's a complete different picture when it comes to movable assets. And they are basically the 99% of the shop floor. So everything that moves is rarely connected currently. So the equipment, the people, the boxes, the load carriers, the vehicles, everything. It's there, it's a lot, and you need that for the factory, but it's not so connected. You don't really know usually where is it. And so far there is no real category or management system that is really optimizing and analyzing this system. But we believe that's changing. Because when you look at the current, like a factory here, this is very, very simple. The model here looks empty, right? And this is like it is today. If you would only connect machines, it looks like this. But the reality of your factory is this, because you have many things on it. You need for production logistic, the workers, equipment, material, boxes, carrier units, vehicles, all that stuff. And now imagine what we say, bring that from unmanaged to managed things. So we say go beyond digitizing just the machines. You need everything for the whole process to be connected. And that's basically the big trend for what we see now, what we see in the future, because connecting machine was in the last years, or is sometimes for some older machines a problem today, but it is solved. But what is not solved really, and what is coming now, connecting the other things. And how do you do that? Usually you start with the real world. So you have the factory, the physical things. And how do you connect them? Usually simple by sensors, by hardware. You attach hardware to them, similar like connecting machines. You use battery powered devices putting on the movable things. Then you leave. Once you have all that information in a digital form, then you go up the layer, and then it's crazy what you can do with software. Once you have the digital twin, you can do so many things. So from, of course, analyzing the whole processes, everything, it gives you a complete new transparency. But you can also use it for triggering in software events, so automating processes. And of course, stuff like prediction and stuff like that. So once you have everything in digital form, it's completely crazy and very open what you do with your fantasy and software. So this is what usually happens from the physical world to the digital world, but not only the machines, but all the other things. So how does it look like usually? This is a factory floor, a simple one, but what you see here, and of course we have these kind of sensors, but there are other, of course, suppliers, but what you have is different kind of sensors for different use cases. So we have, for instance, sensors for vehicles. So there can be forklifts, can be AGVs. We have so-called e-paper tag, very interesting new stuff where you replace the paper and combine it with tracking. So paperless factory with tracking, very interesting. You have equipment tags, you have asset tags you can place on everything. And of course you have a kind of receivers that gather the data and localizing all the things and the data, and then bringing that to the software platform. So why do you do that, right? I mean, it just sounds obvious, right? Connecting makes sense and so on, but just a couple of examples, what you do and what we already doing. Once you have many things connected and know where they are, you can do a lot of things. One thing, for instance, is an automated tool management. That's what we do with the automotive OEMs. So, for instance, the tool is automatically configured based on which car, on what part of the car it is. Simple, but very effective. And you just can do that because you know where they are. Track and trace, obvious, right? I mean, if you track something, you can track and trace it, and you can use it for all that stuff. Search and find, very obvious. You can automate scans. And what is the business impact usually? Just to give you some examples. So automated tool management, for instance, we were able by automating that location information and then directly in the software setting the right configuration for the tool to save some, let's say 5 to 10 seconds. But this is a lot when you look at 1.5 minute sequence time. So you were able to increase the assembly line speed. One another application and benefit is if you have, when you look at the material supply. So if you know at every second, basically, where are the things, where is my material? You're very flexible. You know when the bottleneck is there or even before. You can be very more efficient, effective in just in time or just in sequence. Or for instance, scan automation. We have customers, they do scanning or they're scanning the things very often. So, but scanning is not a value creating or surely not a value creating process step. So we cut out the whole process because we don't need any scanners anymore. And therefore you save a lot of time. We have customers having 80 to 100 hours a day from the whole staff in just doing scans. So very unproductive time is nothing you get paid by the customer. Search and find is very obvious. I mean, if you look for something, if you search for something, we have customers, they have people searching a lot. Where is the order? Where is the part? Where is everything? Again, also a very unpredictable process step in time. These are the 6 simple use cases, but I will now give a bit more detail on further proven results, what you can do, and then step into really the best practice and then 2 case studies. So obviously, when you're looking at improvement, for instance, quality and process improvement, let's assume you have a lot of the things in the material flow tracked. And you say we have certain principles in our factory that should be followed. Let's say the FIFO principle. So it's very obvious when you have all that transparency, where are the things, at what time it entered that buffer zone or that zone for that machine. You can really directly detect whether you're following or not following certain lean or FIFO principles. So you see directly, and on the next day you see how it really works, or not by like anecdotal evidence. It's just with all data, with every order. Then of course we have customers, when they equip this to the load carriers or to the equipment, they realized by tracking, let's say, where are they every second or every minute, they realized that they had too much load carriers, way too much. Even in peak time, it was like just 60%, stuff like that. It's very obvious. But of course, also stuff like when you look at, I talked about the throughput rate on an assembly line, which is done by cutting out the scan processes. But also when you look at buffer zones, so reduction of the storage, because when you know where everything is and have a very good idea on your flow and the synchronization between the logistics and replenishment and the production line, you can really save spaces, and you do not need so big buffers. That's one thing. And again, when we're looking, for instance, reduction of manual scans is also a big thing, because that's totally manual work, and it's work that is usually not creating any value. This is just a couple of examples, but let's now step a bit into a real life example, what we have done. And I found it usually very interesting to show that on a real life example. So we partnered with BMW. I think you know the automotive industry is very professional, especially very professional when it comes to producing something like cars. So they have optimized over the last 50 to 100 years a lot. But even though there's further room and a lot of room to further improvements by using IoT technology. And what was the goal and the thing on the idea here? So we talked about, it's very interesting to know where are the things and getting many things connected. It's already there, but it's not a lot. But still, there is something in place already. There is GPS trackers on the trucks. There are RFID or barcodes on the things, on the material, on the products. There is something like we are very good in UWB, a very precise RF technology for tracking objects 10 centimeters with 10 centimeters accuracy. So UWB, and there's also GPS. The problem was or is these are all working in their vertical silos, different middlewares, and it was made over the last 10, 20 years. So there is no interaction between, and it's very costly to operate and to maintain all that stuff. So the thing was here, we need a horizontal platform, a horizontal location intelligence platform where all the different location-based or location sources, data sources, so the hardware sources, bringing up their data. Because then you have the whole value chain in, or at least of the location data, which in turn is basically a pretty good proxy on what status they are. So for instance, in what process step. So we have everything in that platform, and then based on that, many different use cases. So far, and it is on the next slide, you see they have identified 80 different use cases, what they want to do now with that enablement, so the connecting of the things and the software they have now in place. They started, it's already done, tool tracking, where, as I said, automatically adjusting and configuring the tool. They have the tracking of the trains inside, routing trains. They have automated quality scans now in place. They automated the material booking and the replenishment, because once there is the boxes coming in or out, a virtual geofence we created in the software, automatically, so no human involved saying, oh, we need more of that, or here we have empty boxes, or we have full boxes, we need more or less. Everything is automated. Then we have integrated RFID. So RFID is also the way, it's called RFID part safeguarding, making sure that it's always the right part on the card, because it's very costly if you change that later. And then, as I said, now in place just this year and last year, like reducing printers and paper in the factory by, once you have that localization infrastructure, you can add simply much more use case. In this case, adding an e-paper tag, and that's, you know, here you go, you have no paper, you have an interaction. You don't usually have an interaction with paper, so the tag has buttons, a status, is interactive with workers. It's a lot more benefits than paper alone. This is something started 3 years ago, and once the platform and the basic were there, as I said, not 80 use cases are there, but many of them already in place. And the whole platform is rolled out over 80% of all factories worldwide. I just brought also a couple of pictures with me, because this is a screenshot of our software. So as a human, what you see on the left top is, it's what I would expect how a digital factory would look like, right? If you have, as I said, everything, the physical world connected, you can display and transfer it into virtual one, and this is here. It's a virtual representation of the reality and in real time. So if the tool moves or the car moves, we see that directly here with 1 second delay. So that's how we humans like it. Of course, all the automation and all the event triggering stuff is underneath, but at least it's very helpful for the people using it. So usability is, of course, very helpful. You see here really that it's a digital representation of the factory. And on the picture below, you also see, as I said, we are not able to only integrate. So location data is pretty standardized, right? It's basically X, Y, Z and stuff like that. And so in the software, of course, we don't care whether it's coming from a GPS or a barcode scan or RFID scan or an RTLS system like UWB RTLS. So we're also able, and now with that technology, BMW is able from the beginning, from the making of a car, the first part, until it's at the store, basically, right? So here we're using the GPS of the car directly. So we can use also a truck GPS and stuff like that, but it's crazy. So they have now the whole transparency from the creation until to the delivery. So this is basically as I said, one very good example of what is possible today in production. Another one is, when you're now looking at the electronic industry, is Continental. We partnered with Continental 1.5 years ago, or yeah, 1.5 years ago it started. And they were saying, we want to use, they call it geolocation. They also identified geolocation as the key enabler for industrial IoT. And they said, we also want to do that in our factory. And so we started in the biggest, I think it's the biggest factory for electronic manufacturing in Continental in Regensburg. It's a really very huge area. And we started with one of the big plants. And so we covered an area of 30,000 square meters and tracking roughly 3,500 objects, so load carriers and vehicles and stuff like that, and roughly 50 vehicles from AGVs also, but also forklifts, different vehicles. And we identified roughly 6 to 7 use cases what we can do there. And this is started 1.5 years ago, and this is really now in production for 1 year or so. And I also brought a screenshot with me here. This is a zoom out of that plant, of that big hall, and then when you zoom in, you directly can get a feeling on what it looks like. So simple. Let's assume you want to search for an order because you're missing or one is overdue, right? So you just type in the order number and this highlights everything is, and then the order is highlighted. You directly know where it is, because I think maybe you can imagine have it in your own production, but we have many customers that really don't know where are the materials and where are the orders and stuff like that. So this is a very simple use case, but it's very effective. Another thing is, once we have generated all the data, we know a lot of the process. And what we can do is here highlighting orders that's supposed to be in another process step, or that enter just the process step and waiting there, so not moving for a very long time. Then we highlight them. We highlight them on the map, but we highlight them and bring a notification to a system via SMS, email, and so on. So they can react, and we say they can basically change the future because they can react on it before it's too late. So this is something which really helpful for them. And with the same technology, they cover many different use cases. 6 or 7 are already rolled out, and they have many more ideas to come, because similar like in the GPS on your smartphone is, once you have started and thought about what can I do when I have the localization and the position of my device, there are many ideas and many things that are coming. Already we have many ideas and many knowledge about what you can do, but almost with every customer we learn that there are other things you can do, and it's pretty interesting. And this is really also what I believe is supporting our view that location is really the key ingredient. And then, of course, our sensors can also transmit the temperature, acceleration, so for collision, stuff like that. But you always need where was it, and so its location is really the main thing. Some impressions how it looked like. I mean, you can imagine that the sensors are placed on the stuff, on the object you want to track, on the AGV, on the load carriers, all that stuff. And as I said, as soon as they move somewhere, we have our visual geofences, and then they trigger something, and they automated a lot of processes just because of knowing where the things are. Yeah, and I think now when I look at time, and maybe there are some questions, I would say thank you for your time, and I'm happy to answer your questions if you have some. Thanks.
Thank you. That was very impressive. And yes, we do have questions. And like you mentioned, time is short, so we just jump right in.
Yes, we have some questions, and I have a personal question later on. But I start from one from the audience. Where do you see personally the status quo of digital networking in the electrical industry, so our industry?
Yes, so I think it's, as I said in the beginning, the status quo is it's just the beginning. I think it's just the beginning, and what's happening now with Corona, the situation is surely accelerating it. we as a manufacturer and supplier of that kind of technology see that. Many customers are coming now and thinking about how can they use technology to help to automate and to optimize and being, you know, competitive. It's at the beginning. It's surely not like RFID and barcodes. They're already there. It's basically the next evolution of that. Not just scanning, but knowing where the things are in real time and making with the combination of different data sources, bringing that whole big picture together. This is just, I would say, at the beginning. But as you see, for instance, Continental, as let's say an electronic manufacturer at least, they started it last year or 1.5 years ago, and they're rolling out this to other factories. So I would say it's in the beginning, but it's I would say, promising future, and COVID situation is certainly accelerating this.
Thank you very much. My personal question, you as the co-founder of Kinexon, I mean, I'm quite impressed of what you're doing, but how did you come up to this idea or to this company? What was the initial?
So yeah, the initial is, and I said, we're offering the IoT technology to different industries. Currently there are two. One is the sports industry, and the second one is now in our manufacturing. It started with sports actually 7 years ago, and we watched the games in television, and we realized that they're presenting the stats of the players. So how many the distance covered, speed, stuff like that. And we were wondering how do they do that, and then we realized it was a very expensive camera-based system with operators, stuff like that. And we thought, oh, maybe there's like sensor technology that can be worn by the players, but then will be open for the masses, so for everyone, because nobody can afford such a system, like in the Allianz Arena, for instance. And that was basically the kickoff 7 years ago. And since then, after 2 years or so, we had our solution up and running and started with the sports people. Then the whole industry 4.0 kicked off, and smart factory was a big topic, or at least started. And then many came to us and say, look, when you are able to tracking the ball and the players very precisely from a hardware perspective, could you just do that with my forklifts or my stuff in the factory? And we said, yeah, why not? Of course. I mean, it's much more complicated to tracking a soccer player or basketball player than let's say a box. But different challenges, of course, different environments. So that's how it started, and then we jumped off the industry or smart factory trend, and was very successful. As you said, 7 years founded, now 220 people, and growing really fast, doubling every year. So that's also supportive in what we believe that is just the beginning, and certainly will stay and will increase.
So I have a question myself, because I feel like this could be one of the main aspects of this whole digitalization topic, and that is the question of the infrastructure. How do you rate the infrastructure that is given right now, and where do you see maybe the hurdles, where do you see the chances, where do we have to improve, and what needs to be done for improving?
Do you mean the infrastructure that's already there with the Wi-Fi access point? Is it like a technical infrastructure, or do you mean another broader view on infrastructure?
No, first I was about to get to your first aspect, but the second one is interesting as well. So maybe we have 2 minutes left. I don't know, maybe is it possible to fit both answers in there?
Yeah, so the first one, when you look at infrastructure, as I said, so there are different technologies. So the infrastructure for GPS is more or less there, it's the satellites. But they're not working indoors. So, and 90% of the value creation is indoors. So for instance, the assembly, manufacturing, storage, everything's indoor. So their GPS is not working. You have usually Wi-Fi. Wi-Fi has a problem. Wi-Fi is not very good in locating. So you need, usually we say, you need at least like 40 centimeters, half of the size of a pallet is a first very good accuracy where you open up to a lot of use cases. Of course, if you can track or be accurate by 2 to 5 centimeters, you can do even more. But let's say 20 to 30 centimeters is good. That's usually a problem with Wi-Fi. So what we do right now, there's own infrastructure, so own devices in my back here, in my virtual background, you see one. And we have now partnering with Wi-Fi access point suppliers by adding a kind of dongle. So what we're using for the precise localization is called UWB, ultra wideband. And actually, this is a new cool stuff that is integrated in the new iPhone. So that's much more accurate than Bluetooth and much more accurate than Wi-Fi. And now getting, you know, industrial grade for basically really providing reliable and robust localization information. So you will have the infrastructure that is needed for localization. And usually the Wi-Fi access points are not working with that. And so that's why you need that infrastructure. But there will be like dongles to enhance the existing Wi-Fi structure.